This is Algebra 2, Lesson 12-5, Geometric Transformations. A transformation is a change made to a figure. The image is the transformed figure. The pre-image is your original figure. A translation is a transformation that slides a figure a given distance and direction without changing its size or its shape. In other words, it changes its location, not its size and its shape. A rotation turns a figure through a given angle about a point at the center. In this particular textbook, all rotations are counterclockwise about the origin. Most textbooks I've ever worked with, the rotations are counterclockwise about the origin. A reflection flips a figure over a given line called its axis of reflection. The lines used in this book are the x-axis and the y-axis, and the line y equals x and y equals negative x, which are your two diagonals. A dilation enlarges or reduces a figure by a given scale factor. Okay, all these are important because that's what we're going to be working with today. Transformations can be performed using matrices include translations, dilations, rotations, and reflections. A 2-by-1 matrix representing a point can be multiplied by a 2-by-2 matrix to rotate the point about the origin or reflect the point across a line. Those are two important pieces of information. So you can write the vertices of a figure as a matrix. For example, we have this lovely little quadrilateral here. Okay? And its coordinates. The x-coordinate will be the first row, and the y-coordinate will be the second row. So this first point here is 0, 0. And then you get the point negative 1, 4. Okay, so we have here's 0, 0, here's negative 1, 4, and then you have negative 4, 2, and negative 4, 0. And they all correspond. So here's the first point, the second point, the third point, the fourth point. And so we can take a figure and translate the vertices into x and y coordinates. Okay? So let's take a look at a figure. Triangle ABC has vertices 1, negative 2, 3, 1, and 2, 3. We're going to use a matrix to find the coordinates of the vertices of the image, translating 3 units left and 1 unit up. We're going to graph ABC and its image, A prime, B prime, C prime. Okay? So let's just start with this. Let's start with the vertices. Okay? So we have 1, negative 2, 3, 1, and 2, 3. Okay, and that's the points for A, B, and C. If you want to use A, B, and C, you put them above if you'd like. We're going to subtract 3x. Okay, so subtract 3 from x. Okay, so all my x values are going to have a subtraction of 3, so we'll add negative 3, negative 3, negative 3. And we're going to add 1 because we want to go 3 units left, that's subtracting 3, and 1 unit up, that's adding 1. So we're going to add 1. Okay, so add 1 to y. So 1, 1. So we're going to add these two matrices together, and then we'll get a new matrix. Okay, so now we have the vertices of the image. Should look like this. 1 plus negative 3 is negative 2. 3 plus negative 3 is 0. 2 plus negative 3 is negative 1. Negative 2 plus 1 is negative 1. 1 plus 1 is 2. And 3 plus 1 is 4. So these are my new. This is now my image. So let's graph the pre-image first, which is 1, negative 2. 1, negative 2 is here. And 3, 1. And 1 is here. And 2, 3 is here. So these would be my original points. The purplish color of the hand, so the purplish. So we have over here, over there, over there. So that would be my pre-image. Okay, so this is A, B, C. Now I'm going to do my image, which is now negative 2, negative 1. Negative 2, negative 1, and we're doing a different color because it's easy to see. 0, 2. and negative 1, 4. So there's A prime, B prime, C prime. And I'm going to do those as well. Let's do blue. So there we have it. The image and the pre-image graph. Obviously, if I was graphing graph, it would be slightly better than using a smartphone. Okay? All right, you can enlarge or reduce a figure with a dilation. We use scalar multiplication to dilate a figure with the center of dilation of origin. In this book, all dilations have their centers of origin, which is nice. So really frustrating to them. So if I'm going to dilate a figure A, B, C, D, E, with A being 0, 4, B being 2, 2, C being 3, negative 2, B being negative 1, negative 3, and E being negative 2, 0, is to be reduced by the factor of 2/3. Find the coordinates of the vertices of the reduced figure. Okay? So essentially, all I'm doing is I'm taking 2/3. Whoops. Got that. Let's go back. There we go. Okay, so I'm going to do 2/3 of a matrix 0, 4, 2, 2, 3, negative 2, negative 1, negative 3, negative 2, 0. I'll do 2/3 of that matrix, which gives me 0, 4/3, 2, negative 2/3, negative 4/3. My first row. And the second row, 2/3 of 4, that's 8/3. 2/3 of 2, that's 4/3. 2/3 of negative 2 is negative 4/3. 2/3 of negative 3 is negative 2. And 2/3 is 0 is 0. Okay? So the coordinates of the vertices after the dilation would be A prime, which is 0, 8/3, B prime, which is 4/3, 4/3, C prime, which is 2, negative 4/3, B prime, which is negative 2/3, negative 2, and E prime, which is, okay, don't be looking at you. Let's fix my E. E prime, there we go, is negative 4/3. Here's the coordinates of the new figure after the dilation. And we have it. All right, rotation turns a figure about a fixed point. You can multiply a figure's vertex matrix by a rotation matrix to find the vertices of the rotation figure. In this book, rotations are counterclockwise off the origin. And you do not have to memorize these. I will have these on the board or on the quiz or on the test as you need them. Properties of matrices for rotations in the coordinate plane. Rotation of 90 degrees, you're going to multiply by that 2 by 2 matrix, etc. 180, 270, 360. So we're going to rotate a figure. I rotate the triangle with coordinates 2, negative 1, 3, 0, and 4, negative 2 as indicated. Graph the pre-image and the image of the same coordinate. Okay, so we're going to rotate it 90 degrees. Okay. So 90-degree rotation means I take 0, negative 1, 1, 0, and I'm going to multiply it by 2, negative 1, 2, 0, 4, 2. We're doing 90-degree rotation. And of course, we're going to use the calculator to do this because it is much faster. You can do it by hand, but I'm not going to make you do it by hand. When we multiply that, we get the following. We get 1, 2, 0, 3, and then 2, 4. And you should put that on the calculator to verify that you got the same thing. Because if you do something different than I do, either you made a mistake or I made a mistake, and we got to come to the bottom of that. All right, so if this is my new image, I got to do my pre-image first, which was 2, negative 1, 2, negative 1, 3, 0, and 4, negative 2, So here is my original image. I'm just going to sketch it faster. Okay, so this was A, B, C. I'm going to do my new image, which is 1, 2, 0, 3, and 2, 4. This is A, prime, B, prime, C. Out, degree. 180-degree rotation. We go back up here, the 180-degree rotation. Negative 1, 0, 0, negative 1. Negative 1, 0, 0, negative 1. Multiplied by 2, 3, 4. Negative 1, 0, 2. When we multiply these, we get negative 2, negative 3, negative 4. 1, 0, 2. Okay. Notice what happens. All the signs change because we rotated 180 degrees, which kind of makes sense. Okay, so original figure, 2, negative 1, 3, 0, 4, negative 2, so here it is. C. New figure, negative 2, 1, negative 3, 0, negative 4, 2. C prime, 180-degree rotation. And last but not least, 270-degree rotation. The 270-degree rotation is 0, 1, making 1, 0. 1, 0. We'll call that by 4. 2. And you do and 1, 0, 2. 2, negative 3, negative 4. Okay, so my original figure, 1, 0, 2, C, 270-degree rotation, negative 0, negative 1, 2, negative 2, negative 3, negative 2, negative 4. There we go. We're not the best drawing these, but you get the idea. Now, to reflect things. Okay, a reflection is either over the y-axis, the x-axis, y equals x, y equals x minus the y equals x. Okay, y equals 0 is the x-axis, x equals 0 is the y-axis, and the two diagonals. So, we're going to reflect the triangle with coordinates 2, negative 1, 3, 0, and 4, negative 2 each line graph with a triangle and its okay, so we're going to do all of these, but only on one coordinate axis, which means I only have to graph the pre-image once each time. Okay? My pre-image, 2, negative 1. I'm going to graph that first. 2, negative 1, 3, 0, and 4, negative 2. Same silly triangle we had before. But now, instead of rotating it, we're reflecting it. I will reflect across the x-axis. The x-axis is 1, 0, 0, negative 1. So there's my x-axis. And then we tell that by 2, 3, 4, negative 1, 0, negative 2. When I multiply that, I get 2, 3, 4, 1, 0, 2. I'm going to, sorry, my sheets are different. I'm going to graph all these simultaneously because it'll be easier. Across the y-axis is negative 1, 0, 0, 1. So notice the only difference is where that negative 1 is. And again, we're going to multiply that by 2, 3, 4, negative 1, 0, negative 2. And when we do, we're going to get negative 2, negative 3, negative 4, negative 1, 0, negative 2. The y equals x line is 0, 1, 1, 2, 3, 4. That one, and last but not least, y equals negative x, which is 0, negative 1, 0, 2, and we multiply those together, we're going to get 1, 0, 2, negative 2, negative 3, negative 4. So now I'm going to graph all 4 of these. Okay. So, letter A has me at 2, 1, 3, 0, and 4, 2. For letter A, and that was across the x-axis, which there is. So I just folded itself across the x-axis. And across the y-axis, we have negative 2, negative 1, negative 3, 0, and negative 4, negative 2. So B is across the y-axis. Next, we took this image here and folded it right across to here, so it's across the y-axis. Now we're going to do the y equals x line. Okay. And remember the y equals x line is the diagonal that goes this way. Y equals x line. Okay. So this one, negative 1, 0, negative 1, negative 2, negative 1, negative 2, negative 1, positive 2, 0, 3, negative 2, 4. So notice it's reflected across that pink line right there. So this is letter C. And last but not least, we're going to do it over the y equals negative x line, which happens to be y equals x line is this one, y equals negative x because the slope is negative. So here we have 1, negative 2, 0, negative 3, and 2, negative 4. So it's across this line. So if you watch, you went from here to here. That was a reflection across the x-axis. Here to here, that's a reflection across the y-axis. Here to here, that's a reflection across the y equals x line. And here to here, that's the reflection of the y equals negative x line. And that's how you can change lots of figures by using a matrix. Very simple to do. A lot of computer programs use this, especially with computer animation or video games. So you'd be amazed at how much programming and matrices they use within computer programs themselves.